I'm afraid I have to speak in English. My German is not quite as good as Sebastian's English, so we'll start like this. The first thing I'm going to do is actually explain a little bit about me and RPD. I think most of the time when I get up and try and tell people how to do things, there's a little bit of skepticism. More of the speakers you'll see today have a hell of a lot more time in the industry, a hell of a lot more education in the industry, and generally probably know a lot more than me. But I started my engineering career when I was about 10 years old. I was involved in the TV show Robot Wars. Does anybody remember Robot Wars? Yep, nerds. And I got involved in that just because why not? You know, behind this TV show, there's a real engineering competition. There's a competition that is purely focused on just how far can you push limits. And there's a weight class that's tiny. It's 150 grams and a 100 millimeter cube, so iPhone-sized robots. And it's just a case of how far can you push things. And so I turned up with my parents building things out of anything I could find. Toys, bits of rubbish, bits of packaging, and just tried to compete. And over the years, I started trying to push things a little bit further. I pushed Google Sketchup to its absolute limits. I think they released several packages based on my crashes. And I started designing things around pneumatics and quite complex mechanical components that were far out of scope of what I could produce at school or in the garage at home. And so it got to the point where I started looking for manufacturers. And so at 14, 15, I went around the world and looked for somebody who could produce components for me, aged, well, far younger than most manufacturing clients, but somebody that would actually take me seriously. And you go around the UK and you speak to machine shop owners, and they tend to be about 60-something, very close to retirement, very, very, very skeptical engineers. And everyone says, well, go to China. And, well, I think that was supposed to be a joke, but it's quite easy to find a Chinese factory. You can Google Chinese factory, find quite a few of them. And at that time, I was lucky. This is before the Chinese manufacturing economy started to understand Google and started to understand the Western way of trading on the internet. And so all of the Chinese factories that were on Google and available to find easily on Google were actually run by Western teams who had moved their manufacturing from the UK, from the US, from Central Europe, out to China for the cheaper wages. And so I started working with these companies and started producing these things. I was designing for a 5-axis CNC, and nobody understood what these components were. Some people were quite scared of what they might be. They were absolutely tiny, very complex pneumatic systems that I was designing to play Robot Wars. And so over the years, I started to build that up, and I started to get quite a lot of recognition for the work I was doing. I wasn't paying much attention to it, but I was blogging about it and I was talking about it. And people started to see that, and they started to say, okay, well, can you do this? Can you fix this? We've heard you're into 3D printing. Can you make me a spare part for my dishwasher? And very mundane tasks, but they were paying a little bit of money. And, these people were quite exciting and important, and they came from an engineering world. And that started to get out of control. And so people would, in a time before LinkedIn, a time before anybody could reference check how old their supply chain consultant was, I started controlling several $1 million worth of supply chain for global companies aged 15. I did that after school. And the sheer reason why I could add something to a public company on their supply chain that they couldn't achieve with the experienced engineers they already employed was because I knew nothing. And it's the power of knowing absolutely nothing and still knowing absolutely nothing that really brings perspective, which brings innovation. And so I'd I'd virtually walk in via Skype or email into an environment and say, well, why don't we just do it like this? And the simple reason for never doing it like that is that that's the way it's always been done. And so why would you change that? But that is the pure definition of innovation. And so we started building something that would be a machine, an engine for creating that effect. How can you bring in people who know nothing about the project they're working on to challenge ideas and to challenge concepts? And so we built this engine that is RPD, and we built this engine to cause problems, cause trouble. We bring in people from submarine industry to work in the airline industry. We take people who are artists in LA and San Francisco and get them to come and work on complex database structures in Central Europe, in Germany, in Amsterdam, and combinations that shouldn't work, combinations that companies really would like to try, but could never orchestrate the compilation of these people. And we do the same for manufacturing. And so in the last 12 months, we've done about 109 projects, product launches, product manufacturing, solving big problems for large companies. And I want to take those and confine them into 6 very, very brief kind of guides to developing a product. And I will state again, I know nothing. And the only reason that I want to present these is as an opinion. I think that there are a million other ways to develop a product. These are my key facts, and I would love you to stand up and challenge them in a few minutes' time when I'm finished. So the first one is about understanding the problem that you're solving. And there's a lot of products being released in the IoT and the wearable sector and sectors around that, that as far as I can see, are being developed for the sake of a product launch. The problem that these tools are solving is not necessarily the problem that really exists. And so a project we got in recently was from a supercar manufacturer. And they just launched their new car, and it wasn't selling. And so they came to us and they said, we want to do something different. We want to do something really, really, really cool. We want to do a glass bonnet. It's a front-engine car. We want to do a glass bonnet. It does 200 miles an hour. We want to put a glass bonnet on it. It's expensive. It's not particularly safe. Probably quite ugly. And so we kind of spent a lot of time with them trying to work out what the real issue was. And it turned out that actually the issue was that all of the R&D budget had gone into this beautiful, beautiful V8 engine and the engine bay. They'd spent all their time and all their money developing something that was absolutely beautiful, and then they put a piece of steel over it. And the problem is that to buy an expensive car and to spend money on a luxury item, you need to have a connection with it. Because the person buying that car is a person. And so what the real issue was is that there was no emotional connection to this car. They couldn't sell it because nobody was that interested. Nobody opens the bonnet every day. And once we'd drawn that back down, we worked out that, okay, well, what is the connection to a car? What is it that you touch and you feel every day? What is it that draws you to your car? What is it that represents your car? And it's the keys. Everybody sits at the bar. As soon as they buy the nice car, the first thing they do, they don't drive it. They go and park it at home, and they go to the pub, and they hold the keys up like this on the counter and just wait until somebody looks at them. And so why is it that if you buy, a £1 million supercar, you get the same car keys that come from the consumer family car that's further down the chain in the same company? It's insane. And so we spent a lot of time just looking at jewelry, just looking at luxury products, looking at, Apple iPhone, looking at Swarovski jewelry, looking at De Beers. What is it that makes a product valuable? What is it that makes us love and want to touch a product? And it's weight, and it's the way that something feels, and it's almost everything that you don't see that makes a product valuable. And so, very simply, in a much, much smaller budget than making a glass bonnet on a 200-mile-an-hour car, we built a new key, and we built a new key around the idea that we're making jewelry. And the concept of one came from an artist who was from Milan, and he designed, very simply, the sculpture of the V8 engine into the keys, and we made them really heavy, and they're made from titanium, and they come in a nice box, and that make all of the difference. And so we took that through, and that's now at a stage where it will soon go to manufacture. So my first kind of guide to you is stop and think and understand the problem that you're trying to solve, and understand what the real problem is, not the problem that's been presented to you, but what is the underlying issue, and what are you trying to achieve? Now, that very neatly moves me on to my next issue, or my next concern that a lot of people have, and maybe don't realize that they have in developing products and developing software as well, is that everything you do and everything you try and sell is for people. You're building for people, you're designing for people, and you're selling to people. So the most important thing that you know in developing product is not your supply chain, it's not your UI, it's not your underlying algorithm, it's who is your customer, what do they want to achieve, and how can you help them do that? And we recently worked with a large software company, an ERP company, a competitor to SAP. And their biggest problem is that software is only as valuable as the amount of data that gets put into it. A project management, an analytics software in a large business is only worth as much data as you can analyze. So how do you remove or at least reduce the barrier to data entry? And it's very, very complicated. From a UI and a UX perspective, it's very complicated. How do you remove fields when you need that data? How do you do this? But the real underlying question is, why is there a barrier to data entry? Why is it that having 30 fields is far harder for a person to fill in than to have 2 fields for a person to fill in? And it's very obvious when you say it like that. It's motivation. And so what is motivation? Motivation is the spent resources, it's money, it's time. And it's motivation on the other side. Is it positive? Is it negative? Is there a risk that you're going to lose assets or resources? Is there a reward? Are you going to gain status? Are you going to feel more accomplished? Are you going to be pressured by your team? The thing that affects us most, any one of us, however antisocial you think you are as a developer or engineer like myself, you are affected by the people around you, what other people think of you, and what you think of yourself is the thing that drives us most. And so how can you develop a solution to that rather than a solution to reducing friction in a user interface? And so some of the things we've done are around how do you reposition that? How do you create a product that speaks to that? Again, another company that we've worked with is a phone manufacturer that I won't name. One of their largest sales channels doesn't sell their phone because they don't understand it. The people that sell that phone are of a, they're at a lower financial standpoint, and so they don't buy the phone, they don't understand the phone, they don't try and sell it. So how do you educate those people? And what they currently do is they push information at them. What they need to be doing is understanding what these people who are selling their phones want to achieve. How can they assist them in achieving these things? And so they become the champions of their product. They become the people who are trying to get everybody to enter data. They become the people who are trying to sell their phone. And it's a very interesting problem. It's one that needs focus. And so once you know why your product is important, what the problem is that you're trying to solve, the question is, how are you going to make it? And that's not a question of technology at all. The first question, if you're going to build a physical product, if you're going to build a connected product, is how is it going to be produced? There's far too many products that are coming to market, coming to Kickstarter that we can review and we can see, and that a large percentage of the audience are looking at and going, well, how is that made? And they say, oh, no, it's fine, we'll work that out. As soon as we've got budget, we'll work out how to make it. That's not how it works. The first thing that needs to be done is understand, well, we know our customer, we know how large our market is, we know roughly what our drop sizes are. So how are we going to manufacture this thing? Is it going to be CNC cut? Is it going to be injection molded? Is it going to be vacuum cast? Are we going to make 1? Are we going to make 10? Are we going to make 1,000,000? There's a huge difference to how you design a product based on how you're going to produce it. And so, third tip, am I on number 3? I think it's number 3, is that you need to stop and you need to consider how this thing is going to be manufactured and start by designing for mold, designing for CNC, and then work out what the product looks like. This is a project we worked on recently with a retailer. They wanted to produce a very, very cheap set of headphones from some OEM components, and they picked 3 or 4 companies to compete on some very basic aesthetic design. 4 people pitched. 3 of them produced designs that were absolutely beautiful, like jewelry kind of designs that could be produced at 50p a unit, insane. But none of them could be made. We started with, well, how many units do you want? 100,000 first drop, 100,000 for every month after that? Fine, it's going to be injection molded. How do we design for injection mold? Then we looked at how it works. And that's a real big problem in the industry at the moment, is nobody's considering how these things are made. People are designing beautiful things, but they're wasted because they have to be changed so much for mold that the first stage of design is irrelevant. And it's a waste of time, and it's a waste of, real good brain power. And so once you're at that stage, you understand the problem you're trying to solve, how you're going to affect the person you want to help solve that problem, how you're going to engage users, and you know how you're going to make this thing, it's time to start experimenting. And so we have a rather complex way of experimenting. There's a lot of ways of prototyping, but our way is to tear up NDAs, get out there and throw things at people. quite literally try and break everything we make. We recently worked with an airline who tasked us to start again. What is commercial flight? What is the future of aviation for passengers? And so we put our heads together, we put all our strange people together and came up with some concepts and some ideas. And the first thing we said before we presented them to those ideas to them is we said, we're not going to sign an NDA. The development of these products will happen live. And so the concept was that we'll develop all of these products, and every 3 or 4 days, a new set of products would be on the plane. And every time you flew on that plane, you'd be testing a prototype product, and we'd be telling you about, how this product was made, how it's quite interesting, give you the forum to input your data. But as soon as you ask somebody what they think, you've poisoned the data that you're receiving. It's psychology. As soon as you ask somebody what they think, they either think very positive, very negative, or in the middle. There's no accuracy to the feedback that you get, or very little of it. And so we looked at how we could input data from those devices while they're being used without people really knowing the exact data that we're taking. So how do you use sensors within a device to continuously iterate and continuously gauge feedback? Things like headphones. We know the data and the things that you're watching, and we know when you put them on and when you take them off. So can we work out whether they're comfortable, whether they're uncomfortable? Are they more comfortable on men than they are on women? Are they more comfortable on children than they are on adults? That kind of data to continuously iterate, and to do that on a very, very rapid scale. Every 3 or 4 flights, we would put a new batch of products on, and we'd use that to continuously iterate. And you could run as many tracks as you want and compare and compare and compare until you compile all of the successful developments into a single track, and you go on with your testing before you go into product development. And what that does is it creates a product that fits. It's a product that really genuinely fits your market. It's a product that genuinely works in the environment it's intended for. There's no assumptions, there's no guesses, there's no samples. It's real, it's genuine, and these are your customers who will buy the products later on. So forget about the NDA. If someone's going to copy your product, they'll have done it far better than you within 3 days of your launch. Don't worry. If you're not good enough to execute better than somebody else, then we'll leave it here. And the last one is fifth one, is probably rather obvious. I could talk about any of the projects. Anything that has been made is understanding your supply chain, understanding the stakeholders that are involved in that supply chain, and building for scale. Now, that doesn't mean going straight to the factory that can produce 1 million units when you only need 1,000 for your Kickstarter launch. That's how will this scale? What are the formats that produce this product? What are the key stakeholders? And what are those costs? How do they scale? Do we understand if Best Buy or Argos or John Lewis or one of these large retailers turned up tomorrow and said, I need 50,000 units by the end of the month? Do we understand how we can scale that? Because if your bottleneck is manufacturing, you will struggle as a company. As far as I can see, the bottleneck to a company should always be sales, not delivery. And so you should always understand how to build that scale and how that thing will scale. And there is no harm in engaging larger scale manufacturers early on and saying, this is the product, I'd like to prep it, I'd like you to understand it, because in the future, we may produce at this scale. There's no harm in that, and manufacturers don't mind. They quite like to know that there is pipeline for them, and they quite like to know that they could forecast some potential production on your product. And so do that, and understand that. And my final one, and my rather kind of bonus prize, is that production does not end. If you're going to launch a product, you haven't really launched a product. Everything you launch is a prototype. Every single thing that you release is a prototype. The more customers you get, the more data you get. Continuously keep iterating. Build your supply chains so that every time you produce a new batch, you can tweak and you can adjust and you can update firmware, you can update the software, you can, build on what you've already built. Never say that what you've shipped is a final product. And I'm going to leave it there. Thank you.